Hello student, I am Mrs. Vandana Patil. Now this is my third video. In the last video, we have studied about the derivative of a functions when the two or more than two functions are added, isn't it? When the so many functions are added, how will you find out the derivative? That we have studied in the second video. Also, if the multiplication of a two function or the multiplication of a three functions, if the function it is in the form of a product form, or if the functions if there is a multiplication of a two or more than two functions, then also how will you find out the derivative? And if your function it is in a quotient form, then how will you find out the derivative? That we have studied in the second video. Now this is my third video, and in this third video it's very important that I am going to teach you, that is the chain rule. The chain rule, it is very important for the function which is composite. Now what do you mean by the composite function? Now you can find out the derivative of a sin x, isn't it? But you don't know the d dx of sin e to the power x, sin log x, sin x square plus x plus 1, isn't it? Now such a function, it is called as a composite function. Now what do you mean by the actually composite function? The combination of a two or more than two function, it is said to be as a composite function, isn't it? Now if you observe this sin e to the power x, here there is a combination of a exponential and trigonometric function. This is the combination of a trigonometric and the logarithmic function. This is again the combination of a trigonometric and algebraic function. There should be a chain of a function, and with the help of a chain rule, we have to find out the derivative of such a function. When the function it is composite, we have to use the chain rule. The chain rule, that is the soul of derivative. हा डेरिव्हेटिव्हचा काय आहे? आत्मा आहे. If once you know the chain rule, once you can able to find out the derivative with the help of a chain rule, then it's quite easy to find out the derivative of every different functions, because there are so many functions. There is a derivative of a inverse trigonometric function, then comes the logarithmic differentiation, then comes the implicit function, then comes the parametric function. After that there is a derivative of a second order, and last the derivative of a nth order. So for all these such a functions, it is very necessary to find out, to study the chain rule. With the help of a chain rule, you can find out the derivative of every function, any function. The function कुठल्याही प्रकारचं असू द्या, कसेही प्रकारचं असू द्या. Once you know the chain rule, you can find out the derivative, right? So first we have to learn, we have to study about the theorem, because that theorem, it's very important. The theoretical questions can be asked in the board, isn't it? The theorem एखादा विचारू शकतात आपल्या थेअरीच्या पेपरमध्ये. So in that way, the chain rule, that is the theorem, it's very important. Now let us see the theorem here. Now see what is the theorem. If y is equal to f of u and u is equal to g of x are differentiable function of u and x, chain rule, and here this is the theorem, and this theorem, it's very important. So mark this, star mark केलेला मी. If y is equal to f of u and u is equal to g of x are differentiable function of a u and x, then dy by dx we have to prove as a dy by du into du divided by dx. Now this is the chain rule. Now see the statement. First, what is the statement? First you have to understand what is the statement. Y is equal to f of u means what? Y is the function of a u. Y is the function of a u means what here? Y it is entirely expressed in the form of a u, like this. Y is equal to u square plus u plus 1, or y is equal to sin u plus cos u, or y is equal to tan square u or sec u, then comes u square, like this. This right hand side should be, it is in the form of a u. That is called as a function of a u, right? When y, right, entirely in the form of a u, then it is called as a function of a u, right? Again, u is equal to g of x. They have given u is equal to g of x. Again, the u, it is entirely expressed in the form of a x, means u is equal to x cube plus x square plus x plus 5, like this. U is equal to, that is sin square x plus cos x plus 5, or u is equal to, you can say tan root x plus sec root x, like this, isn't it? So u, it is entirely in the form of a x. Again, they have given are the differentiable function of a u and x. Means y is the differentiable function of a u. Now what is the meaning of this? Y is the differentiable function of a u means what here? The derivative of a y with respect to u exists. Means what exists? Dy by du exists. Now what is the definition? Dy by du, I have explained this definition in the first video. Dy by du means the derivative of a y with respect to u exists, means limit del u tends to 0, del y divided by del u. Means what is exactly the derivative here? Dy by du. What is the meaning of this? That is the ratio of the small change in the value of a y as well as in the value of a u, and their limiting position, it is called as a derivative. So limit del u tends to 0, del y divided by del u, it is equal to dy by du. Again, u is the differentiable function of x. U is a differentiable function of x. What is the meaning of this? The derivative of u with respect to x exists, means what? Du divided by dx exists. And what is the meaning of this du divided by dx? That is limit del x tends to 0, del u divided by del x, right? Again, the ratio of the small change in the value of a u as well as in the value of a x and their limiting position, it is called as a derivative, isn't it? So if you want dy by du, if you want du by dx, this term, suppose you want, then it is necessary to take the changes in the value of a y as well as in the value of a u. Unless and until you take the changes in the value of a y, in the value of a u, you will not get this term, that is dy by du and du by dx, because the limit del u tends to 0, del y divided by del u, it is equal to dy by du, and limit del x tends to 0, del u divided by del x, it is equal to du divided by dx. These are the changes, but these changes are the numerical. These changes are the real number, isn't it? That is not the derivative. Del y, that is not the derivative. That is the small change in the value of a y. Del u, that is not the derivative, because the derivative, it is changes from function to function. Therefore, don't consider del y is the derivative. Del y, that is the small change in the value of a y. Del u, that is the small change in the value of a u. Del x, that is the small change in the value of a x. Therefore, to prove this theorem or to get such a term, again it is necessary to take the changes. Therefore, I will start with changes here. See, let del u be the small change in u corresponding a small change del y in y, right? काय घेतलं आपण? याच्यात चेंज घेतला. When I take del u with a small change in the value of a u, automatically we will get the small change in the value of a y, because y, it is entirely depend upon u. म्हणून याच्यात जेव्हा चेंज घेतो तेव्हा याच्यात सुद्धा चेंज मिळतो, आणि याच्यातला चेंज आपण कशाने डिनोट केला? del y ने डिनोट केला, isn't it? Again, when this value get change, u मध्ये चेंज झाला, u it is changes from u plus del u. Automatically, since u is the function of a x, therefore when there is a change in the value of a u, automatically we will get the change in the value of a x. Therefore we can write this in turn, this In turn, small change, small change, small change, del x in what here x, because u already get change, because we have take the change in the value of a u, therefore u becomes what here, u plus del u. Since the value of a u get changes, since u again it is depend upon x, therefore whenever you have got the change in the value of a u, automatically you will get the change in the value of a x, and that change I have denoted by what here, del x. Now suppose any fraction is there, 5 by 6. You can write this fraction like this, 5 by 2 into 2 by 6. Can you write like this? Because 2 get cancelled, 5 by 6 remain as it is. In the same way, since del x, del y, del u, these are the small changes, these are the real number, therefore you can write here del y divided by del x, it is equal to del y divided by del u into del u divided by del x. Because these are the real number, del u get cancelled. Here you will get del y divided by del x remain as it is. Since this is a real number, this is the numerical number, therefore you can write like this, isn't it? हे आपण लिहू शकतो, because this is not the derivative, because the derivative it changes from function to function, isn't it? So this is the numerical number, this is the real number, therefore any fraction, this is one of the fraction, and that fraction you can write like this. Next step, you have to take the limit. Limit del x tends to 0, del y divided by del x, again limit del x tends to 0, del y divided by del u, again limit del x tends to 0, del u divided by del x. Now again, by the definition of a derivative, as limit del x tends to 0, del u divided by del x, it is directly you can write as a du by dx. Here also, as limit del x tends to 0, del y divided by del x, you can directly write as a dy by dx. But here, the problem is there. Here, limit is del x tends to 0, and in the denominator, there is a del u. Once, suppose instead of this del x, suppose there is a del u, then you can write del y divided by del u, it is equal to dy by du. Now, how will you change del x in the form of a del u? Because here you can write u is the function of x. u कशाचा function है? x चा function है. And the change in the value of a x, it is approaches towards 0. Therefore, automatic the change in the value of a u also approaches towards 0. Because u is the function of a x. आणि याच्यातला जर चेंज 0 ला अप्रोच होत असेल तर याच्यातला चेंज सुद्धा कशाला अप्रोच होतो? 0 ला. Therefore, as del x tends to 0, you can write del u also tends to 0. Therefore, here you can write, that is, see, limit del x tends to 0, del y divided by del x. Here you can write limit, instead of del x you can write del u tends to 0, del y divided by del u, and into limit del x tends to 0, del u divided by del x. Right? Again, here, this is one. Again, since u and x are differentiable, y and u are differentiable function of u and x. Therefore, by the definition, here the limit del u tends to 0, del y divided by del u, it is equal to dy by du. And here limit del x tends to 0, del u divided by del x, it is equal to du by dx. Right? They have given already, and this value you have to substitute in 1. Here limit del x tends to 0, del y divided by del x, it is by this definition directly you can write here dy by du into du divided by dx, isn't it? By the definition of a derivative. And here also, again, by the definition of a derivative, this you can write as a dy by dx, it is equal to dy by du into du divided by dx. This is the theorem, and this is the very, very important theorem, and that is the chain rule. isn't it? So this rule, it is very, very important. You have to buy this theorem, or you have to first understand this theorem and write down 2 or 3 times, isn't it? Very simple here. Y is the function of a u, they have already given. U is the function of a x, they have already given. And we have to prove dy by dx is equal to dy by du into du divided by dx, isn't it? This rule, it is useful for the composite function. And what do you mean by the composite function? The combination of a 2 or more than 2 function, it is said to be as a composite function, isn't it? So in that way, this rule, it is very, very important. And the chain rule, that is the soul of a derivative. Chain rule ha derivative चा आत्मा है. Once you know the chain rule, you can do any problem, any type of a problem. Now I have taken del u be the small change in u, corresponding a small change del y in what here? Y, isn't it? Once there is a change in the value of a u, and u, it is depend upon x, therefore automatically you will get this. In turn, we will get a small change del x in x. Now this identity you can write like this: del y divided by del x, it is equal to del y divided by del u into del u divided by del x. We can write this in the form of a del, because this is the numerical number, this is the real number. Any real number you can write like this. Then you have to take the limit del x tends to 0, and apply the definition of the derivative, isn't it? So here there is a chain rule, and this is very, very important. Now we have to study how will you do the problem on this chain rule, right? Now see, now you know the formula. First the power formula. See here, power formula, that is ddx of x to the power n into x to the power n minus 1. If there is a x, you can directly write the derivative, that is n into x to the power n minus 1. But if the function, it is like this: if y is equal to, suppose 2x plus 3 whole to the power 5. Suppose here y is equal to 2x plus 3 whole to the power 5. Now how will you do this? Right? In the formula, that is in the chain rule, dy by dx, it is equal to dy by du into du divided by dx. There is an inclusion of a u. Now while using this chain rule, what you have to do? You have to substitute u in a such a way that, so that that function should get into a standard formula. काय करायचं आपल्याला? u ठेवायचं आणि फंक्शनला त्या स्टँडर्ड फॉर्ममध्ये कन्वर्ट करायचं, so as to find out the derivative, right? Then you have to find out the derivative of a u, whatever you have substitute. Now see, simple here, u is equal to, you have to write as a 2x plus 3, isn't it? Therefore y becomes, see, u to the power 5. Right? According to the theorem, y is the function of u. Therefore, you can differentiate with respect to u. Therefore, dy by du, it is equal to x to the power n, derivative n into x to the power n minus 1. U to the power 5 u to the power, what is 4. But we want to find out the derivative with respect to x. Therefore, no need to write u. Whatever the u is there, whatever the term u is there, that you have to write, because your derivative, it is with respect to x. Therefore the right hand side must be in the form of a x. Therefore in place of u, you can write 2x plus 3 whole to the power 4, isn't it? This is number 1, right? You substituted u and you have finded the derivative, and here y becomes the function of a u. You have differentiate with respect to u according to the theorem. Right? Now again, what is u? U is equal to 2x plus 3. Again, if you observe this, u is the function of x. जसं theorem मध्ये सांगितलं, y is the function of a u. U is the function of x. See, u is the function of x. Therefore, here again, you can differentiate with respect to x. Du divided by dx, it is equal to, here 2. Now apply the chain rule. What is the chain rule? Dy by dx, it is equal to dy by du into du divided by dx. Now what is dy by du? That is 5 2x plus 3 whole to the power 4 and into what here 2. Isn't it? Du by dx it is equal to 2. 5 to the 10. 10 into 2x plus 3 whole to the power 5. In this way, you can apply actually the theorem. But if there is a more than 2 function, isn't it? There is only the power function here and there are the combination of the 2 function. If 3, 4, 5 they are added, then you have to write u, again you have to use w, again you have to write v, s, like this. The different variables you have to use, isn't it? So, for that purpose what you have to do, you can directly apply the formula. See, there are the 2 things. First you have to substitute u in such a way that so that your function should get into standard form, right? Then you can find out the derivative, and whatever the u put, you have to find out the derivative. म्हणजे 2 गोष्टी करायच्या आहे तुम्हाला. u ठेवून एकदा डेरिव्हेटिव्ह काढा आणि u बरोबर जे आहे त्याचे डेरिव्हेटिव्ह काढा. 2च गोष्टी करतो आपण चेन रूलमध्ये. एक तर u ठेवून डेरिव्हेटिव्ह काढतो आणि u बरोबर जे आहे त्याचे डेरिव्हेटिव्ह काढतो. u कशा करता ठेवतो आपण? असं सहज म्हणून नाही. टू कन्व्हर्ट द फंक्शन इनटू स्टँडर्ड फॉर्म. जोपर्यंत तुमचा स्टँडर्ड फॉर्म्युल्यामध्ये कन्व्हर्ट होणार नाही तोपर्यंत तुम्ही डेरिव्हेटिव्ह काढू शकणार नाही. isn't it? Now say directly I will do this ddx of 2x plus 3 whole to the power 5. Simple. Now this you have to consider as a u. u to the power 5 ची derivative. Again, x to the power 5 ची derivative 5u, x to the power 4. u to the power 5 ची derivative 5u. Don't write u, write whatever u is, 2x plus 3 whole to the power 4. Right? u ठेवून काढले, u मनातल्या मनात ठेवायचं आहे. And ddx of, what is u? 2x plus 3. See here. Again 5. 2x plus 3 whole to the power 4. What is the derivative of a 2x? That is equal to 2. And the derivative of a 3, that is 0. 5 to the 10. And here 2x plus 3 whole to the power 4. See, you have got this. This is according to the theorem. And this is you can do directly, isn't it? And here, while solving the problem, you have to apply this method. पण जर थेरमच्या खाली एखादं प्रॉब्लेम आलं तुम्हाला सॉल्व म्हटलं 2 मार्काचं थेरम आणि 2 मार्काचा प्रॉब्लेम समजा आलं तर यू हॅव टू यूज दिस मेथड. isn't it? So student, very well remember here, you have to do the 2 things. First, you have to substitute u in such a way that so that your function should get in the standard formula. And you can find out, you can able to find out the derivative. And whatever the u you put, you have to find out the derivative. 2च गोष्टी करायच्या. u ठेवून एकदा डेरिव्हेटिव्ह काढा आणि u बरोबर जे आहे त्याचे डेरिव्हेटिव्ह काढा. Now again the simple example, algebraic. See here, very simple example I will take. Say ddx of, suppose 2x square plus 3x plus 4 whole to the power 3 by 2. See here, very simple, right? Now see what you have to do. Again this term you have to consider as a u. u to the power 3 by 2 ची derivative. What is the derivative of a u to the power 3 by 2? What is the derivative of x to the power n? n into x to the power n minus 1. Therefore, what is the derivative of a u to the power 3 by 2? 3 by 2. u means 2x square plus 3x plus 4 whole to the power n minus 1. 3 by 2 minus 1 means 3 minus 2, that is 1 by 2. Right? u ठेवून काढलं. Now ddx of 2x square plus 3x plus 4. Isn't it? Now here again 3 by 2. 2x square plus 3x plus 4 whole to the power 1 by 2. Now here what is the derivative? 2 remain as it is. The derivative of x square, that is equal to 2x. Therefore 2 to the 4 means 4x. 3x derivative 3 and the derivative of a 4, that is always equal to 0 because that is the constant function. Right? In this way you can find out the derivative by applying the chain rule, isn't it? Now again simple example, suppose I consider 5 minus 4x whole to the power 5 by 3. Again you can consider this as a u. मनातल्या मनात म्हणायचं हे u to the power 5 by 3 means 5u by 3. u to the power means 5u minus 4x whole to the power 5 by 3 minus 1 means 5u minus 3, that is 2 by 3, isn't it? here 5 minus 3 to 2 by 3 and you have to take ddx of कशाची डेरिव्हेटिव्ह घ्यायची 5 minus 4x. Right, again 5 by 3, 5 minus 4x whole to the power 2 by 3. Here again the derivative of a 5, that is 0, and the derivative of a minus 4x, that is minus 4. Right, now 5 by 3 into minus 4 means minus 20 divided by 3, 5 minus 4x whole to the power 2 by 3. This is about the power formula, isn't it? No, this is the algebraic function. We can take the trigonometric, exponential, any function you can consider here. Logarithmic function, suppose I consider like this here. Y is equal to sine cube x. How will you do this? First you have to write sine x whole cube, say sine x whole cube. Then only then you can able to find out u. Now here you can substitute u. Sin x is equal to u means u cube. What is the derivative of u cube? 3u square means 3 sin square x. Right. u ठेवला आपण इथे sin x च्या ठिकाणी. Again ddx of sin x. Right. Now see 3 sin square x. And what is the derivative of sin x? That is equal to cos x. Very simple, isn't it? Suppose I take fourth example, ddx of sec to the power 2 by 3x. Again, how will you do this? ddx of sec x whole to the power 2 by 3, isn't it? Now again this you have to consider as a u. u to the power 2 by 3 चे डेरिव्हेटिव्ह काय तर 2 by 3. u means sec x whole to the power 2 by 3 minus 1 means 2 minus 3, that is minus 1 by 3, and again you have to take ddx of sec x. Right, again 2 by 3, this is sec x whole to the power minus 1 by 3, and what is the derivative of a sec x? The derivative of a sec x, that is sec x into tan x. Now again you can simplify this 2 by 3. Here sec x the power is minus 1 by 3. Here sec x the power is 1. When the base is same, you can add indices. Minus 1 by 3 plus 1 means what here? Minus 1 plus 3 divided by 3. Again 3 minus 1, that is 2. 2 by 3. Therefore here you can write the power of a sec x, that is nothing but what here? 2 by 3, and here into tan x. This is the ultimate derivative, isn't it? So there is a power function, then you have to like this, you have to do like this. You have to substitute u, the find out the derivative, and again whatever the u you put, you have to find out the derivative. दोनच गोष्टी करायच्या आहेत आपल्याला. u ठेवून एकदा डेरिव्हेटिव्ह काढा आणि u बरोबर जे असेल त्याचे डेरिव्हेटिव्ह काढा. नाउ अगेन see, suppose the logarithmic function here there y is equal to log x whole to the power 4 by 3. Right, again dy by dx, it is equal to ddx log x whole to the power 4 by 3. This is again you have to consider as a u. u to the power 4 by 3. What is the derivative? u to the power 4 by 3. 4 by 3 log x whole to the power 4 by 3 minus 1. 4 minus 3, that is equal to what here? 1 by 3. You substituted u and find out the derivative, and whatever the u, ddx of log x, isn't it? Now 4 by 3 log x whole to the power 1 by 3, and what is the derivative of a log x? That is 1 by x. Right? So substitute u ठेवा आणि डेरिव्हेटिव्ह काढा आणि u बरोबर जे आहे त्याचे डेरिव्हेटिव्ह काढा. राईट, नाउ अगेन I will take little bit complicated here. See, I will take the function like this. See, again suppose the sixth example, suppose I take the example like this, sine cube root x. Right, now again if you observe this is a power function, this is a trigonometric function, and this is the algebraic function, isn't it? Now how will you do this here? See, again dy divided by dx. Here first you have to write y is equal to sine root x whole cube. See, sine root x whole cube. right? Now you can substitute, you can able to substitute u here. Say dy by dx. Here u cube. What is the derivative of a u cube? 3u square. Means what here? 3. This is square here. Means 3 sine square root x. Right? Again d dx of. Where you have substituted u? Sine root x. हे पूर्ण बरोबर u ठेवलं तुम्ही sine root x. Right? Again say 3 sine square root x. Right? Again this is sin x चे डेरिव्हेटिव्ह माहिती आहे तुम्हाला. sin x चे डेरिव्हेटिव्ह cos x. sin root x ची माहिती आहे? नाही. sin e to the power x माहिती आहे? नाही. sin log x माहिती आहे? नाही. So this is root x. Again you have to substitute u. Sin u चे डेरिव्हेटिव्ह cos u means cos root x. Again you have to take d dx of root x. Right? Therefore 3 sin square root x cos root x, and what is the derivative of a root x? That is equal to 1 upon 2 root x. This is little bit complication because there are the three functions: power function, trigonometric function, algebraic function. This problem first you have to write like this: sin root x whole to the power 3. Here now you can able to substitute u so as to find out the derivative. u cube चे डेरिव्हेटिव्ह काढता येते तुम्हाला. u cube म्हणजे u to the power 3. What is the derivative of u to the power 3? 3u square means 3 sin square root x. Again d dx of sin root x. Again here you have to substitute u. Sin u चे डेरिव्हेटिव्ह cos u means cos root x. Again d dx of root x. Isn't it? So what is the derivative of a root x? That is 1 upon 2 root x, right? Suppose again I will take the another example. See here, y is equal to tan to the power 3 by 2 log x, right? Again trigonometric function, logarithmic function, power function. Again the three functions are there. Again how will you find out the derivative? First you have to write tan log x. This you can write as a whole to the power 3 by 2. So you can substitute u, isn't it? Here you can substitute u now. इथे जर बघितलं तुम्ही, you get confused where you have to substitute u. Therefore first you have to make the function convenient for us, isn't it? Therefore you can write tan log x. Here tan log x whole to the power 3 by 2. Now you can able to substitute u. Here you can put u. u to the power 3 by 2 ची डेरिव्हेटिव्ह आता बघा. u to the power 3 by 2. What is the derivative of u to the power 3 by 2? 3 by 2 tan log x whole to the power 3 by 2 minus 1. 3 by 2 minus 1 means what here? 1 by 2. Again you have to take d dx of tan log x, right? Now 3 by 2 tan log x here whole to the power 1 by 2. Again here you have to substitute u because you know the derivative of a tan x. What is the derivative of a tan x? That is sec square x. But here you don't know the derivative of a tan log x. Therefore here you have to substitute u. What is the derivative of a tan u? Sec square u means sec square log x. Again you have to take d dx of log x, right? Now see here 3 by 2 tan log x whole raised to power 1 by 2 sec square log x, and what is the derivative of a log x? That is 1 by x. In this way you can do such a problem, isn't it? This is about the power formula, and here the chain rule. एक chain असते पूर्ण, आणि you know the chain, all of you know the chain, and एक एक chain आपण काय करायची? सॉल्व करायचं. काय ठेवून? यू ठेवून. यू ठेवायचं, डेरिव्हेटिव्ह काढायची. यू ठेवत जायचं, डेरिव्हेटिव्ह काढायची. You have to substitute u in a such a way that so that your function should get into the standard 15 formulas. त्या फॉर्म्युल्यामध्ये बसलं पाहिजे. आपले जे 15 फॉर्म्युलीज आहेत डेरिव्हेटिव्हचे, त्यात जोपर्यंत बसणार नाही तोपर्यंत तुम्ही डेरिव्हेटिव्ह काढू शकणार नाही. यू कांट फाइंड आउट द डेरिव्हेटिव्ह, इजंट इट? अगेन आय विल टेक वन मोर प्रॉब्लेम. सी पॉवर फॉर्म्युला. सी y is equal to log of log x whole to the power 4 x u to the power 4. This is you have to substitute as a u. U to the power 4 च derivative 4 u to the power means u means log of log x whole to the power 3, isn't it? Again you have to take d dx of log x, right? Now dy by dx, this is 4 log of log x whole to the power 3. Now again you can't find out the derivative. You know the derivative of a log x. What is the derivative of a log x? That is 1 by x. But here there is a log of log x. Again here you have to substitute u. See, that's a log x derivative 1 by x. That's a log u derivative. Hey u hai apne log u derivative 1 by u means 1 upon log x, right? Again you have to take d dx of log x. Here 4 log of log x whole to the power 3 divided by log x, and what is the derivative of a log x? That is 1 by x. This is about the power formula and this is about the problems, right? Have you got the clear idea? See here, on every formula there are the problems, isn't it? Every formula, right? So the 15 formulas, there are the problem on what here? Chain rule. So, now take the another formula, d dx of root x. You know 1 upon 2 root x, right? फक्त x असेल तर 1 upon 2 root x. But if the problem is like this, again root of x square plus 4x plus 5. See how will you do this? Again this term, total term you have to consider as a u. जसं रूट एक्सचे डेरिव्हेटिव्ह 1 upon 2 root x, तसं याला u कन्सिडर करा. रूट u चे डेरिव्हेटिव्ह 1 upon 2 root u, 1 upon 2 root x square plus 4x plus 5. अगेन टेक d dx ऑफ u ठेवून एकदा काढलं. आता वॉट एव्हर द u, what is u? Again x square plus 4x plus 5, isn't it? See, what is the derivative of x square? That is 2x. And what is the derivative of 4x? That is 4. And what is the derivative of 5? That is 0. And this is 2. Again root of x square plus 4x plus 5. Again if you observe this you can take 2 common. If you take 2 common, you will get x plus 2, isn't it? Isn't it? Here again 2 root of x square plus 4x plus 5. No? Again this 2 to get cancel. This is about this second function, that is the root x. What is the derivative of a root x? 1 upon 2 root x. But if your function, it is in this form here, that is root of x square plus 4x plus 5, this total term, this quadratic, you have to consider as a u. हे पूर्ण u consider करायचे. रूट u ची डेरिव्हेटिव्ह 1 upon 2 root u. u ठेवून एकदा डेरिव्हेटिव्ह काढली. Now what is u here? d dx of x square plus 4x plus 5. Isn't it? This remain as it is. The derivative of x square, that is 2x, and the derivative of a 4x, that is equal to 4, and the derivative of a 5, that is equal to 0. Take another example. Suppose d dx of root of 5 minus 4x. Isn't it? Again very simple. This you have to consider as a u. Root u ची derivative 1 upon 2 root u, 1 upon 2 root 5 minus 4x. Again d dx of 5 minus 4x, right? Again the derivative of a 5, that is 0, and the derivative of a minus 4x, that is minus 4, divided by 2 root of 5 minus 4x. Again 2 2s are 4, means here you have got minus 2 divided by root of 5 minus 4x, isn't it? Now whatever the function, it is in the form of a root, you have to do in the same way. Now again take the another example. Third example, suppose y is equal to root of sine root x, isn't it? Suppose root of sine root x, then how will you do this? See here, again this sine root x you have to consider as a u, means dy by dx. Again root u ची derivative 1 upon 2 root u. What is u? Sine root x. Again you have to consider d dx of u ठेवून काढलं, and what is u? Sine root x. Again 1 upon 2 sine root x. See, you know the derivative of a sine x, you don't know the derivative of a sine root x. Again here you have to substitute u. Sine u चे derivative काय ते cos u, cos root x, and again d dx of root x, and what is the derivative of a root x? That is equal to 1 upon 2 root x, isn't it? So here cos root x divided by 2 root of sine root x, and here the derivative, that is 1 upon 2 root x, right? Again I will take another example here. Say fourth one, y is equal to root of tan of log x, isn't it? Say, how will you do this? Again this tan log x you have to consider it as a u. Here root u ची derivative, again dy by dx, it is equal to 1 upon 2 root u, means 1 upon 2 root tan log x, right? u ठेवून एकदा काढलं. आता d dx of again tan log x. Now you know the derivative of a tan x, but you don't know the derivative of a tan log x. Again you have to substitute u. Where you have to substitute u? See here, this is tan log x, remain as it is, and here this here you have to substitute u. What is the derivative of a tan u? The derivative, the tan x चे derivative sec square x, मग हे u ठेवलं तर tan u चे derivative काय ते sec square u, means sec square log x, right? Again d dx of log x, right? Now this is sec square log x divided by 2 root of tan log x, and what is the derivative of a log x? That is 1 by x, isn't it? Again the fourth problem here of the root x, isn't it? हे केलं आपण. Again take, see here, suppose I consider the another one, y is equal to root of sec 4x plus tan 4x. See this, right? Now see, here again this you have to substitute as a u. dy by dx, root u ची derivative 1 upon 2 root u, means sec 4x plus tan 4x. Again take d dx of sec 4x plus d dx of tan 4x, because this is u. Again if you observe this, you know the derivative of a sec x. Sec x चे derivative sec x into tan x, but here again the function gets changed, 4x आहे. मग परत इथे u ठेवा. sec u ची derivative काय ते sec u into tan u, means tan 4x, and what is the derivative of a 4x? Again 4. Here again this is u. What is the derivative of a tan u? Sec square u, means sec square 4x, and again the 4x, the derivative of a 4x, that is 4, divided by 2 root of sec 4x plus tan 4x, right? Now you can take 4 sec 4x common. What is remain? Tan 4x plus sec 4x, isn't it? Divided by 2 root of sec 4x plus tan 4x, right? This is 2 to the 4. Again suppose x, the function is x, suppose, right? This x you can write in the form of a root x into root x. Similarly tan 4x plus sec 4x you can write as a root of tan 4x plus sec 4x and into root of tan 4x plus sec 4x. असं लिहू शकता तुम्ही. see here, this is 2 sec 4x remain as it is, and here this you can write in a 2 root tan 4x plus sec 4x and into tan 4x into plus sec 4x divided by, see, root of sec 4x plus tan 4x, right? 4x, see, again 1 term, same term in the numerator, same term in the denominator get cancelled. So what is remain here? 2 sec 4x root of tan 4x plus sec 4x. Right? In this way you can do the problem like this here of the root x. Again another one, say sixth one, y is equal to log of cot x. See here, log of cot x, right? Again, this you have to consider as a u. Sin u ची derivative, sorry, root u ची derivative काय येते 1/2 root u, isn't it? See, this is u. Root u ची derivative 1/2 root u means log of cot x, right? Again d dx of log of cot x, right? Now 1/2 root of log of cot x. Here again here you have to substitute u, because you know the derivative of a log x, but you don't know the derivative of a log of cot x, isn't it? Therefore here in place of cot x you have to substitute u. Log u ची derivative 1 by u, 1/cot x. Again you have to take d dx of cot x, right? Now 1/2 root of log cot x, right? Again 1/cot x, and what is the derivative of a cot x? That is minus cosec square x, right? Now this you can simplify like this. See, this is 1/2 root of log cot x. 1/cot means what? Tan. Here you can write tan x, and here again minus cosec square x. Minus sign you have to give here, isn't it? See, minus means minus tan x into cosec square x divided by 2 root log of cot x. This is the answer of this question, isn't it? Again, suppose I will take 7th example. See, y is equal to root of cosec x e to the power x. See this one. See how will you do this? Again this total function, that is cosec x e to the power x, you have to consider it as a u, isn't it? Root u ची derivative, again 1/2 root u, 1/2 root cosec x e to the power x, isn't it? Again you have to consider d dx of cosec x e to the power x. Now again where you have to substitute? Here you have to substitute u, because you know the derivative of a cosec x. What is the derivative of a cosec x? Minus cosec x into cot x. Therefore here, what is the derivative of a, this is u, x into e to the power x, you have to substitute as a u. Cosec u ची derivative minus cosec u into cot u x e to the power x, and again you have to take d dx of x e to the power x, right? And this denominator remain as it is, that is 2 root of cosec x e to the power x, isn't it? Again minus cosec x e to the power x cot x e to the power x. Here again you have to apply which rule? Multiplication rule. x into e to the power x, there is a product of two functions, नाहीतर मग काय करता मुलं? x ची 1 e to the power x e to the power x. That is totally wrong. Here again you have to apply the multiplication rule. X remain as it is. The derivative of e to the power x e to the power x plus e to the power x remain as it is. The derivative of x, that is equal to 1 divided by root of cosec again x e to the power x. Right? In this way you can find out the derivative of a function, that is root x, that is the composite function, right? Again I will take one more problem. See here, that is the last on this formula. See, y is equal to again root of log x. See, very simple. See, again what you have to do here, this is again you have to substitute u. dy by dx रूट u ची डेरिव्हेटिव्ह, प्रत्येक वेळी u म्हणा तुम्ही, रूट u ची डेरिव्हेटिव्ह 1/2 रूट u means log of log x, right? Now ddx of what is u? Log of log x, right? Now here 1/2 root of log x, here this is again u, log u ची डेरिव्हेटिव्ह 1 by u means 1/log x, and again ddx of log x, right? Now 1/2 root of log x, 1/log x, and what is the derivative of a log x? That is 1 by x. This is about the chain rule, isn't it? So the ddx of root x is equal to 1/2 root x, and I have taken the problem on this formula, right? That is the chain rule. Now the third one here, see, suppose I take, see here again y is equal to 1/x to the power n. What is the derivative? dy by dx is equal to minus n divided by x to the power n plus 1, right? Now see the first one, y is equal to, suppose, very simple, 2x plus 5, only this one, isn't it? 1/2x plus 5. Now what is the power? 1. This you have to consider as a u. याला काय कन्सिडर करायचं? u. 1/u to the power 1 ची डेरिव्हेटिव्ह किती येते? 1/x to the power n ची डेरिव्हेटिव्ह मायनस n डिवायडेड बाय x to the power n plus 1. मग 1/u to the power 1 ची डेरिव्हेटिव्ह मायनस 1 डिवायडेड बाय 2x plus 5 whole to the power n plus 1 means 1 plus 1 2, isn't it? Here you have substituted u, therefore ddx of 2x plus 5. See again minus 1. What is the derivative? 2x ची डेरिव्हेटिव्ह 2, 5 ची 0, again 2x plus 5 whole square, minus 1 into 2 minus 2 divided by 2x plus 5 whole square, right? This is about the chain rule, isn't it? Again I will take another one, say simultaneously you can write also the problem and you can do yourself. See here again 3x square minus 4x plus 5 whole to the power 3 by 4, right? Again how will you do this? See, dy by dx, again this you can substitute as a u. 1/u to the power 3 by 4 ची डेरिव्हेटिव्ह काय येते? मायनस n means what? minus 3 by 4 divided by here 3x square minus 4x u to the power n plus 1 means 3 by 4 plus 1, म्हणजेच काय करायचं? 3 plus 4, that is what you have 7, 7 by 4. इथे u ठेवलं, u ठेवून एकदा डेरिव्हेटिव्ह काढली. नाव what is u? ddx of 3x square minus 4x plus 5. See, very simple. Again minus 3 remain as it is. What is the derivative of a 3x square? That is nothing but 6x minus 4x minus 4 divided by 4 3x square minus 4x plus 5 whole to the power 7 by 4, right? Here again 1/x to the power n. What is the derivative? Minus n divided by x to the power n plus 1. What is the function I have taken here? 1/3x square minus 4x plus 5 whole to the power 3 by 4. This whole function 3x square minus 4x plus 5 you have to consider as a u. 1/u to the power 3 by 4 ची डेरिव्हेटिव्ह minus n means minus 3 by 4, u to the power means 3x square minus 4x plus 5 whole to the power n plus 1 means 3 by 4 plus 1 means 3 plus 4 7 by 4. u ठेवून एकदा काढली. Now what is u? 3x square minus 4x plus 5. What is the derivative of a 3x square? That is 6x and minus 4, right? Minus 4x minus 4, 5 is 0, right? Again I will take one more problem. See the third one. Third, that is y is equal to 1 upon sine cube root x. See, how will you do this? Again, y is equal to, first you have to write like this, sine root x whole cube. Now it is easy, it is convenient to substitute u. Now you can put u in a convenient way. Now here you can put u. 1 upon u cube चे derivative, सांगा आता 1 upon u cube चे derivative minus n means minus 3 divided by sine root x whole raised to power, what here 4, isn't it? Again d dx of sine root x, right? Now minus 3 divided by, this you can write as a sine to the power 4 असं पण लिहू शकता, sine root x whole to the power 4 किंवा sine to the power 4 root x असं पण लिहू शकता. Now again here you have to substitute u. Sin u चे derivative cos u means cos root x, and again the d dx of root x, that is nothing but 1 upon 2 root x, isn't it? Therefore in this way you can do this problem. Again fourth one, say that is y is equal to 1 upon tan 3 by 2 log x. How will you do this? First you have to write the function in a convenient form, tan log x whole to the power 3 by 2 असं लिहायचं बघा. Now here you can substitute u, 1 upon u to the power 3 by 2. 1 upon u to the power 3 by 2 चे derivative काय येतं? Here minus n means minus 3 by 2. u to the power n plus 1 means tan log x whole to the power 3 by 2 plus 1 means 3 plus 2, 5 by 2. Right? Here you have substituted u. Again you have to consider d dx of tan of log x. Right? Now see, minus 3 divided by 2 tan log x whole raised to power 5 by 2. Now again here you have to substitute u. You know the derivative of a tan x. Tan x चे derivative sec square x, पण tan log x चे derivative means tan u चे derivative sec square u means sec square log x, and again you have to consider d dx of log x. Right? Now see, this is minus 3 sec square log x divided by 2 tan log x to the power 5 by 2, and here the log x, the derivative of a log x, that is 1 by x. This is the result. Right? Again I will take the last year one more problem, fifth one. See here this. Right? प्रत्येक फॉर्म्युल्यावर आपल्याला प्रॉब्लेम तयार करता येतात, and once you know this detail you can do any problem of a derivative, right? But you should know the chain rule very deeply. Right? Again I will take here simple one, 1 upon log of log x. See, now again if you observe this, there is a no power, means what is the power 1, and this you can consider as a u. Dy by dx, it is equal to, again this is 1 upon u to the power 1, and it is equal to 1 means minus 1 divided by log of log x, n plus 1 means what here, 1 plus 1 2, इथे 2. Again you have to take d dx of log x. Right? Now here again dy by dx minus 1 log of log x whole square. Here this is u. Log u चे derivative 1 by u, 1 upon log x, and again you have to consider d dx of log x. Right? Now minus 1 divided by log of log x whole square. Here again 1 upon log x, and what is the derivative of a log x? 1 by x. Right? So this is about the third formula, that is 1 upon x to the power n. What is the derivative? Minus n divided by x to the power n plus 1. So I have taken all the mixed problem that is the composite function, that is the combination of a two or more than two function. And again in the next session I will take again more problem on the remaining formulas.
चॅनलला सबस्क्राईब करा, व्हिडिओला लाईक करा.
Manu? And if you like my video, please subscribe my video, subscribe my channel, isn't it? And again, if your suggestions are there, again you want detail, then give me the suggestion. If you like my video, then share it and subscribe my channel.